So lesson 7-8, just going to talk about geometric probability. There's a few different styles of geometric probability we need to look at, but for the most part, probability is still probability. It's what percent you have of accomplishing what you want out of the total possible options. Okay, so if I flip a coin, I have two possible outcomes, bless you. And so the probability if I had is 1 out of the two possibilities. So it'd be 1 out of 2. If I draw the ace of hearts out of a deck of cards, the probability of that happening would be 1 out of 52. Now if I say I'm going to draw a heart out of a deck of cards, that would be 13 out of 52, which reduces to 1 out of 4. Right? There's only 4 suits, right? So probability is still probability. Moving along. Geometric probability is a favorable measurement divided by the total possible measurement. It's a favorable measurement divided by the total possible measurement. Pause while you copy this down in the example. Favorable measurement divided by total possible measurement. So if we look at this ruler here, we're going to look at the metric side, 0 to 15. They're not really centimeters anymore on this size of the screen, but that's originally what they were. So what we're saying is the flea is going to land somewhere on the edge of this ruler between 0 and 15. And we want to find what's the probability that they'll land between 7 and 10.
2 out of 15.
Okay? And so we'd have to look at that and say, well, what would the measurement be? How much of the ruler is between 7 and 10? How many of the units? 3 units. 7 to 10. It's 3 units.
It says between 7 and 10.
Yeah, and so from here to there is 1, 2, 3. So there's 3 units there. And so my favorable measurement would be if he lands on one of those 3, somewhere in those 3 units. Okay? Now how many possible were there on that ruler? 15. So the probability would be 1 out of 5. Or if they asked for it as a decimal, you'd say 0.2. Or if they asked for it as a percent, you would say 20%. Okay? Quite often probability is a fraction. It's always between 0 and 1. If a probability is of 0, then that means, what about the situation? It's impossible. It's not going to happen. Okay? The probability that I'm going to win the lotto tonight is 0. Because I, what? Didn't buy a ticket. Okay? What's it up to? Maybe I should go buy one.
Gotta play to win.
Gotta play to win. There you go. The probability that you're going to have a quiz today is 1, because you absolutely are going to have a quiz today. 100% chance you're going to have a quiz. Okay? 100% chance there's a little snow on the ground this morning. All right? So the probability is a 1 means it's going to happen. Absolutely. All right? So moving on. I'll pause so Audrey can write this all down. Ashley randomly throws a dart at the target below. Find the probability that she will hit the bullseye if each ring has a radius of 2 inches longer than the center ring. By the way, even though she has no control whatsoever, she never misses the target.
Oh.
Okay? So she might stand out here and just fling it under their arm, looking the other way, it's still going to hit the target. So the probability that it's going to hit the target is 1. The probability she's going to hit the target is 1. The probability she's going to totally miss the target is 0. Okay? So the question is, how do I find the probability that she hits the bullseye? Well, the area of the center circle of the center circle is pi times 2 squared, because that little blue segment is 2 units long. Okay? So the favorable measurement is equal to 4 pi. Because that's where she wants to land, is in that center circle. And so the area of that center circle is pi r squared, where r is 2. 2 squared is 4, so I get 4 pi. Okay? Don't round. Almost always this is going to work out nicely, and if you round, it doesn't. In fact, quite often they'll probably say if it's not an integer, leave it in terms of pi or simplest radical form or whatever. So the question is now, how long is that red line? 10? You agree? So it's 2, and every ring is 2 inches longer. So this is 2, 4, 6, 8, 10. So I agree, that's 10 units long, 10 inches long. And so the total possible is going to equal pi times 10 squared, which is 100 pi. What was the formula to find probability, geometric probability? Favorable measurement divided by total possible measurement, right? So favorable over total. And so that's 4 pi. It's actually inches squared over 100 pi inches squared. Okay? Now, probability never has units in it. And if you look at this, you should be able to see why. Because what happens to my units? They cancel each other out. Anything else cancel? The pies cancel. Oh, man, there went Christmas. No pie. No. Sorry. Now, what else happens? Okay, how? There you go. 4 goes into 4 once and into 125 times. So my probability of a bullseye is going to equal 1 out of 25, which as a decimal I think is 0.04. Okay? And that I think I know it is. All right? 4 100s. That's what we started with right here. Okay. Any questions on how to find geometric probability with a target, something like this? Now yesterday, you looked at some kind of strange looking pieces, right? You had some rectangles, you had some circles, you had some circles missing out of the rectangles, half circles, things like that. Well, today you're going to look at the same kind of situation, except now they're going to say, what's the probability that it lands in that shaded region? Okay? Well, let's look at this one first. What's the probability that she lands on a green ring? This will be the last one. Let you copy it down. Time on your quiz. So, find the probability that she hit the green ring. Remember that each ring has a radius of 2 inches more than the ring inside of it. And so, we have 2, 4, 6, 8, 10. So the total possible is what?
3 out of 4.
The total possible would be pi times 10 squared, which is 100 pi. So that's my total possible. Now I can throw units on there, but remember the units are going to cancel, and so there's really no reason to worry about that. Now, the rest of it's going to be kind of hard. Okay? I shouldn't say hard, it's going to be a little bit messier. How do I find just the area of the outer ring?
What?
How do I find the area of just the outer ring?
Find the area, then subtract the inside.
This area of this right here. Say that louder, please.
You find the area of the whole circle, then subtract the area of the inner part. And
Okay, so if I take that off from there. Take that off from there. So if I take the area of the whole thing, which we just found, and subtract from it the area of that circle, right? I'll get the area of just the outer ring. And so let's do that. Let's go area of the outer ring is going to be, no, let's do this. I'm going to label this differently, sorry.
I'm kidding.
Are you kidding me? I'm not kidding you.
I didn't say me. I just said are you kidding?
Let's say area, this is the outside circle, so we'll call that 5, 4, 3, 2, 1, okay? So the area of circle 4, and so that's going to be pi times 8 squared, which is 64 pi, right? While we're doing this, let's find all of these. Area of circle 3, it's going to be pi times what? 6 squared. It's going to be 36 pi. If I want to find area of circle 2, pi times 4 squared equals 16 pi. And if I want to find the area of the first circle, the innermost circle, it's going to be pi times 2 squared, which is 4 pi. Okay? So, if we call it the bullseye, the middle ring, and the outer ring, those are the 3 green ones, right? And so to find the area of the green, we have to add up all those individual areas. So the outer ring, we just said, is the total minus ring 4, right? And so 100 pi minus 64 pi gives me 36 pi. That's going to be the area of my outer ring. Okay? How do I find the area of my middle ring? Okay, the middle ring is right here, right? You agree with that?
Oh, yeah.
Okay, and so if I take this circle, which is circle 3, and subtract from it this circle 2, that'll give me the middle ring, won't it? And so, area of 3 minus area of 2 is 3 was 36 pi, and 2 was 16 pi. And so my middle area, my middle ring is 20 pi. Do you agree with that? Yay or nay?
Yeah.
Okay, good. And then the middle ring is, the middle circle is, or I'm sorry, the bullseye is just the bullseye. There's no subtraction needed, and that's this right here. And so my favorable measurement is going to be 4 pi plus 20 pi plus 36 pi, and my total possible was 100 pi. So how many pi's on top? 60. C. Over 100. What's that reduced to? Say louder, please.
6 over 10.
Okay, the pi's cancel, a 10 will cancel, and 6 over 10 is 3 over 5. That's what I thought someone said. 2 goes into 6 and 10, 3 and 5 times. Okay? So my probability of green is 3 over 5. So notice P of G doesn't mean P times G. It means the probability of green in this case. That's what G stands for. Okay? All right. A little bit more complicated, isn't it? But still not impossible. Okay? All right. We're not going to do this one. But let's talk through it. How would I find the probability to land in one of those gray circles or bluish gray circles? Yes, Hunter.
Find the area. Find the area of the rectangle, which would be 24 feet squared,
Yeah.
and then you find the radius of one circle, which would be 1. And then you
Anybody
find
know
the area-
why it's 1?
Because 4 foot is the direct middle of 4 foot is the circle. So each of the circles' diameter is 2.
There you go. So halfway, if the whole thing is 4, then this is 2. So that means the diameter was 2. So the radius then would just be 1 of each of them. And so I find the area of the 6 circles. Area of 1 times 6 would give me the 6 of them, right?
Yeah.
That'd be my favorable divided by my total, the rectangle. Okay? All right, we're going to stop there. Today's assignment was 4 through 24 by 4s.
What was it?
Is that right, Hunter?
Yeah.
4 to 24 by 4s.
Oh, okay.
So you have 6 problems to work on. You have a quiz to take. And you have a test tomorrow, group form. Ready?